Okay, so this is the ArcMap interface. We discussed this in the previous presentation. This is what we have. In mine, I've already put in a few things because it in this image analysis and classification, things go a little bit slower depending on how powerful your machine is. So I tried to put mine already there so that we don't spend a lot of time just waiting for things to happen. Okay, so what we are going to do is you're going to import your image here, your images, all of them, because when you download that image from USGS, depending on the band, the and also the band of your sensor, that's how many images it's going to give you. So if it gives you, if you're choosing images from Landsat 8, you're getting 8 images for that particular scene because there are 8 bands. It's giving you different bands of that image. So all of them, you go wherever you kept your data. And did you see how I went there? You just come here, add data, and navigate to the place wherever you have kept your work and pick it up and then put it in, which I have already done. They are here. So when I turn them on and zoom them to layer, there you are. Now the question is, how do you know it's properly in the right place? When you put the Uganda boundary, I told you that I'm going to be classifying Lake Opeta. Lake Opeta is a small lake on Lake Choga, on the ends of Lake Choga. So when you put the Uganda boundary and zoom it to layer, and probably put the water boundary, the water thingy. So this one here is Lake Choga. You see that? And this little, when you remove this image, that little thing here is Lake Opeta. Is everyone seeing what I'm seeing? Okay. I'm going to assume everyone is with me. So when you put the image there, how do you know it's there? First, you can check the properties of your image. And when you go in here, you will see that it's actually having spatial reference. It's there. Kasacha,
Yes, please.
I'm going to call you up to just know that we are together because people are not talking. But if you look, I don't know if you're following how I got here, but when you check the properties of your image, you will see that it has spatial reference information, which means it's actually georeferenced and it's in the right place. So when you keep adding all your images, you'll have a whole lot of things going on. All of them, these are all images from one scene, from one area. Now, when you look at this one here, you see, it is actually highlighting your Lake Opeta properly. This one here is Lake Opeta. This one. And this is the extension of Lake Choga. There. Okay. So what do we do when we bring our images in and they are already at level 2 processing? We create a composite from all of them, like it's like joining them together. Yeah. How do we do that? But before we go there, you need your image analysis window active. So you come here in customize. If it's not yet ready, active, you come here in customize, go to extensions, click on them and just check everything because you're going to need Axin later on in other analysis. You'll need a 3D analyst, you need network analysis, publisher. So your spatial analyst is here. If it's not checked, please check it, or you can just check everything. So we are going back to what we're doing. So when you come in here, create a composite out of this. I told people that who downloaded images that had scan lines that you can remove them. ArcMap doesn't have that extension, but you can go in your QGIS with the same concept. It's the same thing, but it has that extension of removing scan lines and you remove them. So what you do, or when all your images are here, you create a composite. How do you do that? You go to the toolbox or just come here to your search bar and type in composite. We are looking for the composite bands of data management, of your data management tool. Okay. So when it comes up here, you add all your rasters, all of them. You can add them from here. You can add them from here. Or you can just grab one here and just keep adding like that. Or you can highlight them, all of them together, control down, and then click one by one and grab them and drop them there. So they are in there. Yeah. So when you have put all the rasters that you want to composite, you can define where your raster should be kept and the name. So I leave mine in the default for the ArcGIS, and then you say, okay, I am not going to do this because it's going to take some time and we don't have that time. But you do it and let it run. So when it runs, it's going to produce for you this. Let me just remove that. If I'm losing you, please let me know. Okay. So this is the composite I get after. Don't worry, we are not yet at Lekopeta. We are at the image we got. Yeah. So when you get this this composite, now you have to create a true color composite. A true color composite means what you're seeing now is not the true, is not what you see with your eyes when you look outside. Yeah. So this is a color that is false. It's not true color. So you want to create a true color composite. You want to make this image actually look like the way it would look like out in the field. Yeah. So what you do, you come to your composite now and right click on it and go to properties. So you come here to symbology. Okay. You come here to symbology. What you would see when you open up this is that your bands are going to be red is going to be band 1, green is going to be band 2, and blue is going to be band 3. So what you want to do is to change that and change your red to band 3. You just click on these drop down arrows and then change your blue to band 1, like switch, flip, yeah? And then apply and say okay. Yeah? Kasacha, we follow it.
Yes, we can hear you and we are following.
Okay. So the next step would be you having to remove all the no data values. For example, your image is just this box here, but then it has these black little things outside. And also, you never know, within the image, you might have no data values, which might mislead your classification. So you need to remove those ones so that your image, yeah, is just only showing pixels that have data to it, to them. Okay, so how do we do that? You come back here to your search window, or you can just go to data management and check the data management toolbox to get your tools. But I prefer just typing them here. Okay, so what do we need to remove those data, those no value data points? data values. So what we do is copy this image actually. So I'll just copy that, copy raster. Data management. Now, when this window opens up, you put the raster that you want to copy. In this case, it's the one that ends with a 201, this one. Define where you want to keep it. So I'll leave it in the default. Then come here to the node data value option there. Yeah? Remove this number that is there and put 0. Are we together? And then say, okay, and let it run. Kasacha, are we together?
Hello,
Yes.
Aisha.
You are together.
There is a question in the chat since you asked if we are together.
Yes.
Someone is asking why was the presenter changing the figures for the different bands? Green for
Yeah.
one.
I was trying to change to create a true color composite from a false color composite, and that is how you change them.
Okay, I hope he's answered.
Okay,
Thanks.
so
Yes, I've got it. Thank you.
okay, you're welcome. So going back to trying to remove the no data values. In this window that opened, make sure this place here. Let me do that again. So you check in here and search your copy raster tool. From data management, we have different toolboxes. So we are going to use data management because that's what you're going to be doing today. I'm using this raster, the first raster that the composite that I made, and then changing the data values from the number that appears here to 0. And then running, just say okay and go ahead. I said I'm not going to run these things because they take a lot of time while we are just looking at them running. So I took it upon myself to try and do them earlier. So when you run, okay, it's going to create for you a raster without the points. So that's what you'll get. It remove all the no data values and you only have pixels with data. So what do we do next? What do we do next is focusing our classification on the area of interest, which is in this case, Lekopeta. I already have the boundary around Lekopeta, so it would be nice to add the boundary of the area you want. So when you zoom into this area, this is the area. This is the only area that I want to classify. Yeah. So I don't want to go through the whole thing. So what I do, I'm going to clip my raster only to keep only the area that is around Lekopeta. That is the next step. I'm clipping out my area, my raster. But I need you to note that the raster is a raster, and what I need to use to clip is a vector. So I can't use the geoprocessing clip. I can't. So what I do, I go to data management still and pick up my clip. Okay, so here you are. Please let me know when you're not following. Okay, so this is the clip, and you see this clip comes different from the clip from geoprocessing. So you put in the raster that you want to clip here, which would be raster number 4204, this one. I told you that I clipped these things earlier so that my presentation goes smoothly without having to wait. Yeah. But otherwise, you just click there on the raster that you want to clip, then define the extent you want to clip it with. That is when you can pick up a vector extent. So in this case, it would be Lekopeta. And when you put in the extent, it's going to define the y minimum, y maximum, x minimum, and x maximum. And then if you want, it can clip for you and give you a box, a very well shaped square. But you can also want to clip and only have the boundaries of the vector that you have put in. For example, this time Lake Opeta. Yeah. So if you want it to go around Lake Opeta, just only around Lake Opeta, you'd click this particular uh, box. Check it, keep it checked to make sure that it goes only around Lake Opeta. But if you want a box, just a box around the area, then don't click it and then say okay, and it will clip it for you. Now, when I clipped, I did not mind if it runs around Lake Opeta or not, just the region around. So that's why it's looking like this. I think I should clip and we see if it, no, it will, you can try that out. But this is the clip I get, and it's just focusing on Lake Opeta. Are we together, Kasacha?
Yes, we are together.
Okay, let me know if I'm running too quickly.
No, actually, there is just a comment in the
Yeah.
chat.
Yeah?
Yeah, because
What's
it's Lex, it's from Emma. Because it's Lex, blues was right for Lake Opeta, they thought. I think he's talking about the colors.
Ah,
Yes.
okay. So what happens is the image we got from please don't be confused by the actual colors that you know. These sensors pick up these colors differently. That is why you need to know the sensor you're using. Now, for example, if you're in the easiest example is the NDVI. In the NDVI, vegetation is picked up as red. Yes? Not green, because green is different. But the vegetation is picked up as what? As red. So when we made a composite from our many bands and made a composite, what we had was not the true color. It was the false color. For example, this one. Let me do this for you. So what you see now on the screen is the false color. This is not the actual color. This is not how you see Lake Opeta when you go out there or when you take a picture with your phone from the aeroplane. This is not how you see Lake Opeta. That is why we change it from the false color composite to a true color composite by changing this the way we did it the other time. Just flipping it, apply, and okay. Okay. Now, you know we are looking at images, images picked up by the sensors of the electromagnetic wave. So what you see as the pinkish, yeah, the pinkish is actually vegetation. It is not water, because Lake Opeta has been over the years eaten up by the water weed, by the lake weed. So what you see as black, what you see as black is actually water. Now, in the sensor language, in remote sensing language, this is the true color. Do you get what I'm saying? So, what you're looking at, wherever you see a pinkish thing, you're looking at vegetation. Black is water. Then we have brown, we have the silver, whitish. Those are built up places, roads or homes. And then we have bare lands, we have rocks. It's a whole series of things, but you're going to try and do something today. Yeah? Okay. So we are looking at Lake Opeta. After clipping it out like this, going back, now we can start our classification. The classification we are going to do today is supervised classification. To do a supervised classification, you have to create training samples. That means on your toolbars, you should have this toolbar called the classification toolbar. You remember I explained to you how to get these things here. Okay, so you come here at this point, the training sample manager, click on them, yeah, and then come back here on the polygon and click. You can choose to draw circular polygons, draw square polygons, or just draw a polygon. I just take up the polygon all the time. So what you're going to do is to create samples that the software is going to use to classify the rest of the image. So I try to zoom in, not you zoom in to try and not mix up the pixels that are close by. For example, if you look at this area, you see there's a little bit of blackish, but there's also a pinkish. Now, if you draw a polygon around this place and call it vegetation, you're likely to have your water classified as vegetation. And you're drawing these samples from a point of no. You know the area you're working with, and you also know how your colors are changing. So when you start, these samples are small little, you just click around and double click at the end. Now you see in your training sample manager, you have created the first class. But we need to create more of these that show that that is water. So wherever it finds it, it puts a vegetation because this is not water. So this is also vegetation. Let's find another place here in that blackish, darkish place here. Take this up as vegetation. Then you see, I try to zoom in, zoom out, zoom in, zoom out, so that I see which areas I'm not representing. This is what I'm doing is creating training, a training sample. Okay, so come here, put this as a vegetation as well. Let's go somewhere in here. Okay, so we need all this to be picked up as vegetation. When you zoom in, you see the different pixels. So you can zoom out. Now, when you go outside Opeta here, there's this little bit here. I need it to be classified as vegetation as well. Even this one. I'm picking out the areas that don't really look, I know they are the same, but the computer might see little variations and call them differently, and I want them to be picked up still as the same thing. And you can also have different types of vegetations. So I might be picking out now a water hyacinth, but probably there's another vegetation here that is not that, and it is also reflecting the the IR and the red radiations differently. So you need to also note that and don't miss it. Okay, so for training, that is for vegetation. But now when you look in your training sample, you have multiple of them. You have all these training samples as vegetation, and they are calling themselves differently, like 1, 2, 3, 4, 5. But I need all of them to be one as vegetation. So you pick out one by one. I mean, you click on one and hold down your control button on the keyboard and highlight them. Highlight them like that. Now, when you highlight them, you can, this whole keyboard, these all buttons become sensitive because they think you want to use them. So what you're looking for is to merge. So we want to merge all these training samples and they should have one value. So when you click, they are all now one value. When you go back to, let me remove the image and you see, now they are all the same. I hope we are following. Now let me classify something else. So I've finished, but you can go in detail a little bit more. So let me do something else now. Remember where our first classification is. Okay. Okay, but I want all these little things to be picked up as water too. So I'm classifying water body. Okay. So I want these ones also to be picked up. You see, there's a little bit of black, but it's mixed with a pink. So I want these ones to also be picked up as water. That is why I'm going to try and tell this software to also pick anything they find looking like this as water. But be careful not to confuse it. It will give you something you will not even believe. Okay. Let's go with that for now. But also in here we have different variations. Those would be nice to pick up. Some of these. Okay, so let's go with that for now. So we go again and merge these last ones that we have done. You hold down the control button on your keyboard and click one by one and then merge them. So now all those, let me remove the image that you see. So now the yellow ones are going to be our water bodies.
Madam Aisha, just a second.
Yes, please.
Yeah, Male Emmanuel, please, you need to mute. Male Emmanuel.
Okay. Go on.
You can go on. Madam Aisha, please, we can't hear you speaking. Madam Aisha.
Oh dear.
I think she has,
Yes,
she
I'm
has
here.
muted.
Sorry. I don't know how that happened, but I was in the middle of saying that because we are doing a supervised classification, it's very important that you're very careful when you're picking up your training samples. Because if you make one mistake in your training sample and you're classifying one class wrongly, you're going to base on that to make your analysis, and your analysis will be wrong. So picking up these training points is it's I think the biggest part of supervised classification. So I had picked up the gray part that I was telling you about, that we needed to pick up the gray. Now I'm trying to pick out the white. Okay. So I'm going to merge that. Okay. Are we following though? So I have managed to make 3 classes out of this image. You can make as many as you can, depending on how much, and also following the guidelines of classes of LCLU. Okay, so after getting your classification, your training samples in order, you have to create a signature file. And we are doing all that here in the training sample manager. So you come here, it's on the far side, far right of this training manager. You click on it to create the sample, the signature file. Now you can decide where you want to keep it. You can define the area we want to store it, but I'll leave it there for me. And then you can give it a name. You can rename it, probably signature Lekopeta. Okay. So after that, you save. Are we together, Kasacha?
Yes, we are together.
Okay. So now you go back to your classification toolbar here. Make sure that the image you're working on is the one here. Yes?
Okay.
Okay, my images are the same, so it doesn't matter anyway. But you have to make sure that it's the image you're working on is the one here. So we will keep with the number 6 because it's the one you've been working on anyway. And then when you come to the classification toolbar, you come here in classification and choose the supervised classification technique or algorithm that you're going to be using. I'm going to use the maximum likelihood classification. The ISO cluster is unsupervised. You need to note that. Don't use it when you're doing your supervised classification. Then the class probability and principal components. So I'm going to use this one, and there are reasons why that I'm not going to go into now. Now, when you go in here, the raster is here. The one that I want to classify is here already because I clicked and it's in here. Then you have to input your signature file, the one that we have created from our training samples. So you come here. So we're going to go with this one. I call this signature Lekopeta. Okay, and add it just like that. Then you can go ahead and define where you want to keep your classified image. I'm not going to do that. And then you can also go and check on the environments, depending on what analysis you're looking forward to. And then you can go ahead and allow it to classify. Okay. So when you look on the lower right-hand side, you'll see it's classifying. So when it finishes, it does that. So it has classified our image depending on the training samples that we made, and they are right here. So let me close this one. You see, it has brought our classified image. Let me remove the one that is not. And we have class 1, we have class, we have this class, and this class. These are values, raster values. We shall come to that later. Now you have a classified image. When you put back what we were classifying, this is how it looked like. Let me remove the boundary of Lekopeta. This is how it looks like. And then when you put this, you see the difference. It's, if you look at this area here, just to appreciate how it has classified depending on your training samples. If you look at this area here and you switch between this and that, you see that some portions of the water were not picked up because those pixels, we did not remove them. Are we together?
Okay.
Okay, so this is now our classified image. What do we do next?